Let's start with a quick recap of our flipped video 1.2, the PPC. So in our flipped video, we learned about the production possibilities curve and the three assumptions that we work off of when we're talking about the PPC. The first assumption is that a nation only produces two goods. The second assumption is that that nation will operate at 100% efficiency. And then the third assumption is that we have fixed resources and technology. So those are the three assumptions that we're working with. And from our macroeconomic perspective, we pay attention to three different points on the production possibilities curve. The first set of points that we pay attention to is the efficiency points. And anything on the efficiency curve is fully efficient. So points A, B, and C are all fully efficient. They are using our resources wisely. They're on the efficiency curve, so they have to be efficient. If we want to produce at point A, that's fully efficient. Same thing with B and C. The only thing that changes from moving from A to B to C is what we're losing and what we're gaining by changing those points of production. But anywhere on the efficiency curve is 100% efficient. We're using our limited resources wisely. The second point that we want to pay attention to is point X, and this is the inefficient curve. So if it's on the inside of the curve, it is inefficient. Now, everything on the inside of the curve is a valid point of production. If everything on the efficiency curve is fully efficient, valid points of production, anything on the inside is also a valid point of production, but it's inefficient because we're not using our resources wisely. And for our purposes in class, we're going to assume that that is due to unemployment. And then the final point that we pay attention to on the PPC is point Y, and it's on the outside of the efficiency curve, so it is unattainable. If A, B, and C that are on the efficiency curve are 100% efficient, using all of our resources wisely, then there's no way that we can produce at point Y. But we care about our unattainable point because that's our goal for growth, and we always want to have that in the back of our minds as we're trying to grow our economy. So let's review calculating the opportunity cost and the opportunity gain off of production possibilities curve. So remember, opportunity cost is what we lose from a decision, and opportunity gain is what we benefit from a decision. So this nation is producing computers and textbooks. So let's look at the opportunity cost and the opportunity gain of going from points A to B. So we're going to identify the costs and the opportunity gain of that change in production. So point A, we can make 9 computers and 20 textbooks. And we're going to change production to point B. And at point B, we can make 8 computers and 40 textbooks. So what is the cost of going from A to B? Well, computers, we go from 9 to 8, and textbooks, we go from 20 to 40. So what did we lose by moving from A to B? Well, we lost 1 computer. Now, what did we gain from going from A to B? Well, we gained 20 textbooks. Now let's look at changing production from B to C. Again, we're going to look at the opportunity cost of that change and the opportunity gain of that change. So we're going to go from B to C. So at point C, we can make 5 computers and 60 textbooks. So at point B, we have 8 computers. And now at point C, we have 5 computers. And then for textbooks at point B, we have 40 textbooks, and point C, we have 60. So what was the cost of changing production from B to C? Well, that's 3 computers. And then what's the gain? The gain is 20 textbooks. So that's how you're calculating the opportunity cost and the opportunity gain off our production possibilities curve. So let's look at some practice problems drawing and manipulating the PPC. So I would draw these on a piece of paper so you can practice drawing them. You do have to know how to draw the graphs for class and for the AP test, so you want to make sure you are practicing drawing the graphs. Something that's super important is labeling correctly. So you can see there's already these words horizontal and vertical. So horizontal is side to side, vertical is up and down. So there's an increase in unemployment in a nation using all of its resources to produce boats, which is on the horizontal, and cheese balls, which is on the vertical. Label your efficiency point as A and your increase in unemployment as B. Well, our efficiency point is easy. It's anywhere on the curve. So I'm going to put it kind of in the middle and label that point A. And now we have an increase in unemployment. So unemployment on our production possibilities curve is a sign of inefficiency. So where should point B go? It should go on the inside. So anywhere on the inside would be fine to place point B. And that is a fully drawn and labeled production possibilities curve showing a change of increasing unemployment in a nation that produces cheese balls and boats. Let's look at the second problem. Again, I would draw this out on a piece of paper and practice drawing and manipulating these production possibilities curves. Suppose a nation using all of its resources can produce computers, which is on the horizontal, and salad dressing, which is on the vertical. The citizens of this nation express a want for more salad dressing. Label your efficiency point as A and the change in production as point B. Well, let's just pick a point on the efficiency curve and label it A. Now, the citizens want more salad dressing. So are we going to go closer to salad dressing, or are we going to go closer to computers? Well, we're going to go closer to salad dressing because that's going to show an increase in producing salad dressing. Now, we're still making computers. We're just making less computers. We're making more salad dressing because that's what the citizens want. But both points A and B are on the efficiency curve. We didn't lose any resources. We didn't increase unemployment. We didn't become inefficient. All we did was change our production pattern, our production possibilities, to focus more on making salad dressing. So let's look at a third problem here. Sketch out our PPC. Suppose a blight destroys 80% of the potato crop in a nation using all of its resources to produce potato chips, which is on the vertical, and bolts, which is on the horizontal. Label the original PPC curve as 1 and the new curve as 2. Well, here's PPC 1. Now, blight is some sort of like agricultural attack on agricultural products. And it destroyed 80% of the potato crop. Now, to your general knowledge, just using common sense, do you think potatoes are used in the production of bolts? I don't think they are. So are we going to have a tremendous impact to our bolt production because we lost potatoes? No, we're going to have a big impact to our potato chip production, but our bolt production shouldn't change all that much. So our second curve is going to look something like this. And there's curve number 2. Now the bolts are going to have some impact to production because we only make 2 products. So the resources that we need for both bolts and potatoes are going to be limited, but our bolt production didn't change all that much. What did really change was our potato chip production because of that significant loss of our potato crop. So how do we determine how countries trade? So our production possibilities curve tells us what a nation can make, so what products they're able to produce. But now we need to figure out who's going to trade what. And later on in the semester, we'll talk more about trade. So this is just a very quick introduction to how trade kind of starts to happen. We only want to trade if we are going to gain from trade. No one, and this is even in the real world, is going to trade if they're going to lose something. Think about all the trades that you make in class or with your siblings or, with your friends. You're not trading things for nothing. How many of you trade homework answers for nothing? No. If you're going to trade your physics homework, you want something in return. Same thing with countries or nations when they're trading. They want something in return. So there has to be a gain from a trade deal. Otherwise, we're not going to trade. So when nations start to talk about trade and think about trade, they're only going to trade things that they can't make on their own or that they can't make efficiently. So before we determine who's going to trade what, we have to figure out what the nations are going to specialize in. So that means a nation is only going to make one good or service. So when we are talking about specialization, we're going to force nations to only make one product, and that's it. They can't make two, they can only make one. So when specialization happens, all of the resources go to that one product. So if we talk about our potato chips and bolts example, if that nation was going to specialize in bolt production, they would make no potato chips. So all the products and resources that they use to make potato chips would disappear, and everything would go straight to bolt production. But how does a nation determine what they should specialize in? How do we help nations figure out what they should specialize in? We don't want them to just pick randomly. There's actually a process that we go through to figure out what nation should trade what product. And that process is called trade advantages. So we need to figure out which nation has the advantage for trading that one product. So there's two ways that we can figure out trade advantages. The first is through absolute advantage, and this is just who can make the most. So if Tom can make 5 shirts, but Lisa can make 10, who makes the most shirts? Tom with 5 or Lisa with 10? Lisa. That's absolute advantage. Or it's in the least amount of time. So it takes Tom 1 minute to make a shirt, but Lisa needs 2 minutes. So does Tom have the absolute advantage by making 1 shirt in 1 minute, or is it Lisa that needs 2 minutes to make 1 shirt? Well, it's Tom. He only needs 1 minute, and Lisa needs 2. The second type of advantage that we can use to figure out who should trade what is comparative advantage. Comparative advantage focuses on the least opportunity cost of producing a product. And this is called true specialization. So the most efficient way to determine a trade advantage is through comparative advantage, because we are going to look at a true specialization for that one product. You can use absolute advantage, but comparative advantage takes into account the opportunity cost, or what we're losing to produce the other product, and focuses on true specialization. So one thing we need to kind of keep in the back of our minds when we're talking about trade advantages is, are we talking about inputs or outputs on our production possibilities curve? So inputs go into the production of a service or good. So that would be time, energy, materials. So back to the Tom and Lisa example, it takes Tom 1 minute. Well, minute is a form of time. Lisa takes 2 minutes to make 1 shirt. Again, time. So that's all inputs. They both made 1 shirt, but Tom only needed 1 minute and Lisa needed 2 minutes. We could also talk about like lumber or energy. We could also look at, different forms of time like days or hours. We could talk about people. That would also be an input. Output is just the number that's produced. So if Tom can make 5 shirts and Lisa can make 10, that's output. We're just talking about the number that they can produce. So let's practice calculating absolute advantage first. So Alice can make 12 shirts in 1 hour and Ben can make 10 shirts in 1 hour. Well, we see something in common, 1 hour. So we know this can't be a time question. So we're looking at the 12 and the 10. So who's going to have the absolute advantage in making shirts? Well, that's going to be Alice, because Alice can make 12 shirts and Ben can only make 10 shirts. The US can produce 200 computers and Japan can produce 400 computers. Well, we're talking about production, so we're talking about output. So the US can make 200 and Japan can make 400. Which number is bigger? 400. And Japan is going to have the absolute advantage in producing computers. And our final example, China takes 30 minutes to produce one iPhone and the US takes 45 minutes to produce one iPhone. Well, something that's in common here is one iPhone. So now we're going to talk about time. So China takes 30 minutes and the US takes 45 minutes. So who can make one iPhone in the least amount of time? Well, that is China. So China would have the absolute advantage in that example. Now, calculating comparative advantage. So comparative advantage is that true specialization. So we have to figure out the opportunity costs. Remember, comparative advantage is the least opportunity cost to produce a product. So that's what we're looking for. So our first step in calculating comparative advantage or determining true specialization is we have to determine if we're talking about an input problem or an output problem. If we're talking about inputs, we're going to go under. Now, what does this under mean? Well, when we set up our ratios, we are going to move under when we create our ratio. An output, we're going to go over. And again, when we create our ratios, that means we're going to go over. So if it's an input question, we're going to go under. If it's an output question, we're going to go over. Now, one thing to keep straight is when you're calculating comparative advantage, you need to make sure you're staying within the countries or within the people. So you see how our table's set up here. We have our nations or our people, Ted and Nancy, and then what they can make in each product. So Ted can make 3 radios or 12 wheats. Nancy can make 2 radios or 4 wheats. So that's how you want to set up your table. So do we think this is going to be an input problem or an output problem? Well, there's no signs of time or energy or anything like that, so it's pretty safe to assume this is a production question. So this is going to be an output problem here. So we're going to go over. So watch as I set up my ratio by going over. So I'm going to take the 12 and put it over the 3. And then I'm going to take the 3 and put it over the 12. And I'm going to do the same thing for Nancy. I'm going to take the 4 and put it over the 2. I'm going to take the 2 and put it over the 4. See how we went over? That's how we're setting up our ratios to figure out our opportunity costs. So how are we going to determine our opportunity costs here? Well, first, let's look at radios. So I'm going to put a 1 here. So we're going to figure out the opportunity cost to Ted to make 1 radio. So it costs Ted how many wheats to make 1 radio? Well, 12 over 3. Well, what's 12 over 3 simplified? That's 4. Yes, 4. So 1 radio costs Ted 4 wheats. So every time Ted makes 1 radio, he's giving up 4 wheats for that radio. And then what about Nancy? So 4 over 2 is 2. So when Nancy makes 1 radio, she gives up 2 wheats. So every time Nancy decides to make a radio, she is losing 2 wheats to that radio. So between Ted and Nancy, who has the least opportunity cost to make 1 radio? So who's giving up the least amount of wheat to make 1 radio? Is it Ted who's giving up 4 wheats, or is it Nancy who's giving up 2 wheats? It is Nancy. Nancy has the least opportunity cost. So Nancy has the comparative advantage in radios. So Nancy is giving up the least wheats to make 1 radio. Remember, least opportunity cost. She's giving up the least wheats to make one radio. So she has a comparative advantage in radios. So now let's look at the wheats. Put a 1 over here. So 1 wheat costs Ted a fourth of a radio. And then 1 wheat will cost Nancy half of a radio. So who's giving up the least amount of radios to make 1 wheat? Is it Ted who's giving up a fourth of a radio? Or is it Nancy who's giving up half of a radio? Well, it's Ted. A fourth is smaller than a half. So Ted is going to have the comparative advantage in wheats. Ted is giving up the least amount of radios to make 1 wheat. So his opportunity cost to make a wheat is smaller than Nancy's. Now there's some things that we can look at to make sure we set up our ratios correctly. If we look at Ted gives up 4 wheats or a fourth of a radio. 4 and 1/4 are related somehow. They are the reciprocal, correct? Same thing with Nancy. She's giving up 2 wheats and then half a radio. 2 and 1/2 are related. They're reciprocals. So we know we set up our ratios correctly when we have the reciprocal of each other. So let's look at an input question. So input is under. So if we have an input, we're going to go under. And we're going to follow the same process that we did for the last example. We're just setting up our ratios by going under. We still have the people or the nations set up. So we're going to work within the people or the nations. And then our products are on the columns here. So we're going to go under. So we're going to take the 10 and put it under 8. And then we're going to take 8 and put it under 10. We're going to take 12 and put it under 16. We're going to take 16 and put it under 12. See how I went under when I was setting up my ratios. Now we're going to follow the same process as the last problem here. 1 car. So how many planes does ABC have to give up to get 1 car? We'll weigh 8 over 10. Let's simplify that. So if we pull a 2 out of both, we're going to get 4/5. So ABC, when they want to make 1 car, they're giving up 4/5 of a plane. And then let's look at XYZ. So when XYZ wants to make 1 car, how many planes are they giving up? Well, 16 and 12, if we pull a 4 out of each, we're going to get 4 and 3. Yes, 4 and 3. So every time XYZ makes 1 car, they're giving up 4/3 of a plane. So who is giving up the least planes to make 1 car? Well, that would be ABC. 4/5 is less than 4/3. So ABC is going to have the comparative advantage in cars. They're giving up the least planes to make 1 car. So let's go over to the planes. 1 plane is going to cost ABC how many cars? Well, it's going to cost them 5/4 of a car to make 1 plane. And then what about XYZ? XYZ is going to give up 3/4 of a car to make 1 plane. So who is giving up the least amount of cars to make 1 plane? Well, that's XYZ. 3/4 is less than 5/4. So XYZ, since they're giving up the least amount of cars to make 1 plane, will have the comparative advantage in planes. So that's how you determine comparative advantage with an input and an output problem here. There's another way that you can be shown a production possibilities curve with determining determining trade advantages. So you could have a PPC that looks like this. Now we don't have our table, so we have to set up our table here. So I'm going to go ahead and put country A and then country B and create a table here. So we are making corn and computers. So my table's set up like the other two, and now I'm going to pull the numbers. So country A can make 800 corns or 200 computers. And we're talking about quantity, so this is going to be an output problem. So we're going to be going over. So country A can make 800 corns or 200 computers. And then country B can make 400 corns or 500 computers. So this is an output problem, so we're going to go over. So I'm going to have 200 over 800, and then 800 over 200, 500 over 400, and then 400 over 500. So let's look at our opportunity costs here. I'm going to change color since my boxes are a little small here. So one corn is going to cost country A how many computers? Remember, we're looking for the opportunity costs, and we went over. So we're going to do 200 over 800, which is going to give us a fourth. So one corn costs country A 1/4 of a computer. Now let's look at country B. So country B, one corn costs them how many computers? Well, the only denominator is 100. So if we pull 100 out of both, we're going to get 5/4 of a computer. So who's giving up the least computers to make one corn? That would be country A. So country A will have the comparative advantage in corn because they're giving up the least amount of computers to make one corn. Now let's go to the computers. So how many corns is country A giving up to make one computer? Well, they're giving up 4 corns. And then what about country B? Well, country B is giving up 4/5 of a corn. So who is giving up the least amount of corns to make one computer? Well, that is country B. So country B is going to have the comparative advantage in computers. So that's how you determine absolute and comparative advantage. So now we're going to go back to our first problem here, our first practice problem, and we're going to figure out the acceptable terms of trade. So terms of trade is what's acceptable for a good trade deal. Now, you never want to trade for less than what it's going to cost you to make a product. So Ted is losing 4 wheats when he makes 1 radio. So does it make sense for Ted to give up 5 wheats for 1 radio? No, he gives up 4 when he makes his own radios. So he's not going to give up 5 wheats when he makes 1 radio. Now Nancy, when she makes 1 radio, she's losing 2 wheats. So does it make sense for Nancy to trade 1 wheat for a radio? No, it doesn't make any sense. If she's going to make radios, she wants in return at least 2 wheats because that's what her cost is. So to figure out terms of trade, we just look in between the opportunity costs. And we just find a number in the middle of the opportunity costs to figure out the terms of trade. So if we're looking at 1 radio, how much should a radio go for in terms of trade? Well, it should go for 3 wheats. 3 is in between 4 and 2. And then let's also look at 1 wheat. So 1 wheat should go for how many radios? It should go for 1/3 of a radio. So that's the term of trade for this problem. So let's look at this one. We would find a number in the middle. That would be our terms of trade. And this one happens to be pretty easy because 1 falls in the middle of both. So the terms of trade for A, B, C, and X, Y, Z would actually be 1 for 1. So 1 plane for 1 car. That would be an acceptable terms of trade for A, B, C, and X, Y, Z. And then let's look at country A and country B. Well, again, we're looking in the middle of our opportunity costs here. So our terms of trade, let's look at 1 corn first. So how much should 1 corn go for between country A and country B for computers? What should we trade 1 corn for 1 computer for? Well, we just want something in the middle. 1 would work. 1 is in between these two numbers. You could also do 3/4 of a computer. So let's do 3/4 of a computer. That's in the middle. And then let's look at 1 computer. How much should we trade 1 computer for in terms of corn? Well, again, we just want something in the middle. So we could do 3. We could do 2. So let's do 2 corns for 1 computer. That would be an acceptable terms of trade.